Hi, in this video we're going to finish our discussion of 14.5 part 2, or maybe finish and then have one more video, we'll see. So, there's two extensions of the concept of the chain rule. In the last video, we talked about chain rule concepts where there's one independent variable at the end of the day and two intermediate variables. So, extension number one would be, what if we had more intermediate variables? So, for instance, the example of that situation would be W equals tan inverse or arctan xz, ooh, already interesting, plus z over y. And now we would need equations for each of these intermediate variables. Something like x is t, very lame, y is t squared, and z is sine of t. Okay, so what would the tree diagram look? I really recommend you always make a tree diagram. Well, the tree diagram would have W as the root. And what would be the branches off of W? Now we'd have 1, 2, 3 branches off of W. One for X, one for Y, one for Z. And then each of these is only dependent in one direction. So you should have either made this tree diagram, which again is going to be more and more relevant as we go through the work. Or you could, in this case, because they're all based on the same variable, rejoin them all at the end. I would just recommend going back to this one, which looks a lot less nice, but it's going to be what we're used to in the very next example. So what does this tree diagram say about the chain rule here for the components? Well, what it says is that the derivative of W with respect to just time, there'd be 3 paths to watch out for. There'd be the path contribution from X, which would go dW dx. How much does that change in X contribute? Times how much the change in T affected the X. Plus, straight down, how much did changing Y affect W, times how much the change in Y was affected by the change in time, plus the last branch. So each time we're seeing where can we go to get all the way to T. So that last branch would be the contribution based on Z to W, and then the contribution of Z based on T. Once you get this formula, you should be able to do all these derivatives now. They're a little annoying. You might have to look up the tan inverse rule, but I suggest you pause the video and try this out. 3, 2, 1. With respect to X, we'll have to handle this guy. For arctan, or tan inverse, 1 plus what was inside squared times the derivative of what was inside times its chain rule component with respect to X, keeping Z a constant. If it said tan inverse of 5X, I would put a 5 on top, times the derivative with respect to X. Sorry, the derivative of X with respect to T is just 1. If you're wondering what happened to Z over Y, that's 2 constants. That's like 3/5. Okay, when we're taking the derivative with respect to X, that's just a constant. We're going to ignore it. Likewise, now we're doing dW dy. With respect to Y, this tan inverse is a constant. Gone. Careful with this one. Again, I suggest that you've already paused the video. You've already done everything you're supposed to do. I would get negative z over y squared. Then we would look at y with respect to time, which is 2t. One last one to go. dw with respect to z. Now that should be pretty easy for the tan inverse part. We are going to need a bigger parentheses here. It'll be very symmetric to what we had before, just with x on the top, because now x was a constant. And this is the only one where z is in both of these. So plus 1 over y times cosine t. I'm going to squeeze it in there, and we're just going to live with that. So you could rewrite this in all sorts of different ways, but that's the big idea. That's all there is going on here. Is it a little ugly? For sure. Is it horrible to compute? No. But maybe I'm just making you worried. Maybe you're like, well, who knows what you're going to write next? So the other thing we could talk about is having more independent variables. More, I don't know, bottom leaves of the tree. So for this one, we will have to go back to a total partial situation. So say I had, let's see, w equals x cubed plus y cubed, x u squared plus v squared, and y is 2u v. Okay. Now, if I wanted to make a tree diagram, I'd have to consider how many different independent variables there are, because we're going to go down another layer. Or, sorry, not down another layer, but more branching. So w is still the root. If we look at the w equation, we just have x's and y's. If I look at the x equation, we have our u and our v. If we have the y equation, we still have a u and a v. And that's what makes this less and less simple, less and less easy. So we really will have two derivatives of w again. There's no possible way to call it dw du, because there's two letters. So we need partials all over the place for sure. No, this bad. Okay? Now, how to compute such a thing? How to go partial w, partial u? It's the same thing we've been saying. You're going to start from w, and you're going to trace away all the way down to the u's you can get. So we're going to go to x, and then we're going to go to u, partial w, partial x. And now again, this also has to be partial x, partial u. And again, we can check that we're getting something that's going to have these cancel, and these are what we want. Good, that's a good sign. Now we're going to go from w to y, back to u. So dw dy, partial w, partial y, partial u. Try to write down that formula. If you're finding this to be easy, I'll tell you the thing we're going to do after this is do the other partial derivative for w. So, filling things in. Pause the video now. Try to take these derivatives. It's a little, I would say it's not that bad. 3, 2, 1. W with respect to x is 3x squared. X with respect to u is 2u. W with respect to y is 3y squared. dy du is 2v. Remember, you're treating v as a constant. This is not the product rule. This is just 2 times u times 5 with respect to u. And you'd have to find d, oh no, I did it. Partial w, partial v, because w is based on 2 possible letters. So now we're tracing away from w to all the v's. So to x to v, and to y to v. There will be problems that you'll see that will ask you to write out the chain rule so we can at least give you credit. So please practice writing this out. I want to go from w to x, that's what this one's saying, and then from x to v, that's what this one's saying in my handwriting. Okay. Plus the contribution from y times how did y get affected by v. Once you write this formula down, you should be able to go at it yourself. So pause the video right now and try to give me this partial derivative. I really do not like how I'm writing my partials. 3, 2, 1. W with respect to x, notice that that's not changing between these two because they should both be dw dx. Okay, we shouldn't have anything big issue here. This part should. It's 2v because when I look at the x equation, now this is a constant and we're taking the with respect to v plus, again, 3y squared times 2u. I really do not think this is that big of a deal. I think these are really quite doable. Let's do w equals x arctan yz. So we used arctan in the last problem. Let's see how we do with it now. We'll give you x is square root u. Y is e to the negative 2v. And z is v cosine u. All right. I'm going to recommend you try to write your own tree diagram here. Give it your best shot. If you're feeling confident, pause the video and try it out. 3, 2, 1. You know the root of the tree is going to be w. What variables is w based on in its equation? It's based on an x, it's based on a y, and it's based on a z. 3 intermediate variables. And now we're looking at x. What's x based on? Just u. What's y based on? Just v. What's z based on? Z is based on, screwed it up, u and v. So this is kind of as complicated as it can get. Each variable is based off of other variables. There's 3 intermediate, there's 2 independent. What will happen when we write down our rules? I suggest you write down your rules based on this, based on what you're seeing. How many will there be? There should be 2. 1 should be based on u, because we're counting how many variables are down here. There's just 2. So there's 1 based on the u variable, and there's going to be 1 based on the v variable. For the u variable, what's going to happen? We're going to consider the contribution for this w to that u. So that's through x. So we have to go w to x to get from w to x. That's how I'm picturing that. And then from x to u. Then from w to get to, do we have to go to y? No, because y is not going to give us a contribution with respect to u. Y is a constant with respect to u. The whole variable y is a constant, so it's not going to give us a contribution. So we're going to skip the y branch and we're going to go to the z to the u. That's rule number 1. And we're just going to, let's write down the other rule right now. This is a nice space for it. Sorry, I guess I want to use black. Partial w, partial v. Do we want to go to x? No, there's no v's at the bottom of that branch. So instead of going through x, I'm going to skip x, go through y, partial w, partial y, times partial y, partial v, plus partial w, partial z, partial z, partial y. Oh, partial z, partial v. Dang it. Almost messed up. Again, the error check I just did, those cancel, good. But are we getting dw, dv? Now we are. Okay, so we're going here and then here. That's what we're picturing. As I already said, once you have all that written out, this next part shouldn't be that bad. It's just a test of your differentiation capabilities. Really, really, really pause the video. See if you can get this answer. 3, 2, 1. Arctan blah times x. This whole arctan thing is a constant. It's like it says 5x. So the derivative of 5x is 5. Arctan yz. No big deal. Times dx du is 1 over 2 root u, or however you want to write it. You could write it using just the negative 1/2 power. Doesn't really matter. Plus, now we're doing w with respect to z. W with respect to z, it's not a product rule. X is not a variable with respect to z. Then we have arctan. Y is a constant with respect to z. Sorry, x is a constant with respect to z. X is not a variable. I don't know if I said that right. Okay, so we're going to have x, holding on to the constant, over 1 plus the inside squared times the derivative of the inside with respect to z, which is a y, times dz du. dz du is negative v sine u. Again, holding the constant v. So we're just like 5 cosine u. That's this component. If it's still looking confusing, I really recommend trying the next one on your own. Partial w, partial v now. Here, if it's confusing because of my bad handwriting, let me fix that. Try partial w to partial v. It's really important that you actually try these out so you can see what's going on. 3, 2, 1. The first thing we're doing is dw dy. Looking at this with respect to y, it's going to be very similar to this, meaning we're going to hold on to the x, can go in top, 1 plus the inside squared times the derivative of the inside with respect to y. That's this part. Now we're doing y with respect to v, focusing on y with respect to v. We're talking about times -2 e to the -2 v plus, again, these two are exactly the same. You already did that one. Should be no big deal. xy over 1 plus yz squared times, and now we're looking at z, but with respect to v. Just cosine u. We're going to do one more example. Kind of like everything all at once with an evaluation. let's make w equal x squared y plus y squared z cubed. X will be r cosine s. Y will be r sine s. Z will be r e to the s. Okay. The prompt says find partial w, partial s, evaluated when r equals 1, s equals 0. What do you do? Well, the first thing I would do is to make a tree diagram. Please make a tree diagram right now. Make sure you're paying attention to which variables should be used in each of the equations. So w is at the root. W has 3 letters in it. X, Y, Z. Now, pause the video and think about how you should write your next layer, so to speak. 3, 2, 1. Each X, Y, and Z are dependent on 2 letters each. X has R and S. Y has R and S. Z has R and S. But for the derivative they're asking me about, I only really care about paths toward S. So, in symbols now. Try to write this down in symbols. How would you get from W to S? Can you write out that rule? Try it. So you're looking at all the S's on the bottom, and you're trying to write this rule. 3, 2, 1. 1, 2, 3 S's. We're going to get to each of them. First one, I have to go from W to X to S. How do I go with that? I go W to X, X to S, times. Nope, sorry. Then plus. That's always how people mess up. These are always added the branches. We're adding the branches. W to get to Y, then S. This path. So W to Y, Y to S. Sorry, Y to S, like that. And then another contribution from W to Z, and then from Z to S. There you go. That's the rule. Now we're going to try to sub in these derivatives. So, pause the video right now. Try to get me something interesting here. Try to get me something correct, I guess, is more important than interesting. 3, 2, 1. Pause the video. I hope you really did it. Here we go. 2xy plus nothing. No x's. That whole thing just says a constant to me. Now, x with respect to s. I'm doing cosines all night. Negative r sine s. Plus w with respect to y. This is the annoying guy. It's x squared plus 2y z cubed. Y with respect to s now. That's r cosine s. W with respect to z. Now this part's a constant. So we're talking about 3y squared z squared times r e to the s, because dz ds is just your classic exponential derivative where nothing really changes. All right. Now we're going to go try to plug stuff in. When r equals 1, s equals 0, and s equals 0. They might both be different. They don't have to both. When r is 1 doesn't mean s is 0. Okay, I'm not trying to say that. We're both independent variables here. We need to figure out what x is, what y is, and what z is. X is 1. Y is 0. Z is 1. Please triple check that. Did you get that right? And now we're just going to go for it. dw, ds, partial w, partial s, when r equals 1, s equals 0. You could write down all the other ones, but I'm not going to. We have 0, because the y here will be 0, plus times another 0. Doesn't really matter, but this whole thing goes to 0. Over here, I have 1 plus 0. I'll write that. 1 plus 0 is 0. Sorry, 1 plus 0 is 1. It's too late for this. R cosine s, that's another 1, plus y is 0, so this whole thing is 0. So we're talking about 1 as the final answer. You might be saying, well, that was a lot of work just to get that. It's not too bad. It's not that bad. You guys can handle it, I am sure. So, there will be one more video after this. I lied at the beginning of the video. But thank you for paying attention to this one. This is pretty much as complicated as it can get. Just make sure you're paying attention to the paths, and all will be well. See you in the next video. Bye.